So in this lecture, we're going to talk about control theory. And before diving into the details of it, let's try to look at the motivation behind it. So we'll start with a graph problem. We have to reach from point B to point H. And we can reach there using several routes. So we can take different ways to reach this destination. And we need to optimize over these paths in such a way that the cost to the destination is minimized. Now, the idea is that we used to use in classical computer science methods something called Dijkstra's algorithm to find the shortest path. But the disadvantage of that method is that once I find the shortest path and somehow I deviate from it, so rather than reaching point D, I reach point C. And then I am in a dilemma because then I need to calculate the shortest path from this place. So the way we solve this problem is that by assigning specific values to each of these states. So you can see these are different states. If I can assign a particular value to the states such that given a state, and I see that, okay, these are the possible directions that I can go, F or D. And if there is a value associated such that it indicates that if the value here is 5 and if the value here is 10, then I should move in the direction where the value is less. So in this way, I can make a map or I can chart my graph in such a way that now, no matter where I am, from that point on, I can find the shortest path to my destination. And this is the founding principle of dynamic programming, that given a state, if you know the value function, then from that state you can find the shortest path. Now, the way we do in this graph is that we have these weights. So I can set the value of G as 2 because there's only one way I can reach G, and that is from the final state in this direction. Now, of course, the value of the final state is 0. Now, given G and E, now the value of E is also depending upon how you see it. You can either take this path, which is 8, and you can take this path as well, which is 2 plus 3, which is 5, plus 2, which is 7. So in this way, you sort of assign the values to each of these states and you come up with what we call a value function. The value function is a scalar which maps a state to a value, and the basic crux of this idea is that once you have the value function for each of the states, you can navigate your graph and find the shortest path.